Screen is visible or not?
Yes, sir.
Okay. So that type of things you have done before. Actually, I told you during the interpolation why we are studying the interpolation. Suppose any data sets is given to you. By watching these data sets, you are thinking the data is following a pattern y equals to 3 to the power x, and if it is asked to you find out the values of y at x equals to 4, suppose what it will be, then you will put simply this value at this function and you are telling the value. Okay, that is you are thinking looks like 81 it will be, but logically or mathematically this is wrong. That idea I told you, because how you will create this function, it is working in your mind. Decide that if I will change little bit in data sets, suppose 1.1, 3.9, okay, this is suppose I am doing minus like that. Can you able to guess some function such that which type of function following these data sets? Obviously not. So then how you will calculate the values of y at x equals to 4? For that purpose, you have to do the interpolation techniques, and to choose the interpolation techniques you have the algorithm. Suppose for these data sets these are equally spaced and asking point is lying at the ending neighborhood, means at the neighborhood of 3, you will use Newton which technique logically? For these data sets which techniques you will use?
Newton forward.
Newton backward.
If you will use logically, in which way I am teaching you actually, if you will use Newton forward, that is also logically wrong. You have to use Newton backward. Okay, since these values are equally spaced, so you will use Newton backward. If I will ask you, suppose at the point 4 data is given to you and at the point 3 you have to find something, then you have to use Newton divided difference if the values are not equally spaced. Okay, so logic of that, using that idea, I am established here two statements. You just try to study this statement. Number one, with the help of n plus 1 points, suppose your given set of data points are n plus 1 points. With the help of n plus 1 data points, you can able to approximate maximum nth degree polynomial. Is it true? This statement is true or not? And why I have written this maximum word, that is also clear.
Yes, sir.
So express me why I have used here maximum word. Why I have used maximum word?
Because if all the points are in a straight line, then there will be a only 1 degree polynomial. We can draw using 3 points. But if they are non-linear points, then we can draw of like if we have 3 points which are non-linear, then we can draw maximum of 2 degree polynomial.
Okay. So actually, suppose that logic is implemented here also. Suppose I do have 4 points. Suppose 4 points are 4 points are lying looks like this. Here is 1 point, here is 1 point, here is 1 point, here is 1 point. These are the 4 points. Okay, and this is basically a parabola. And this, if you will join these 4 points, you will get this curve, and this curve is nothing but this is a polynomial, and that polynomial is the parabola. Okay, second degree polynomial. Y equals to suppose pi x second degree. Okay. So if you will use this set of data points, these 4 points, and try to construct the difference table, you will get in second difference column, you will get all constant value, and third difference column, you will get 0. Okay. That time, if you will construct the polynomial with the help of Newton forward, backward, or divided difference, whatever. If you will construct, you will get simply second degree polynomial with the help of 4 points. Okay. So if in linearity of joining the points, some curve you are getting, in that linearity, some point is coincide, then your degree will be reduced. But maximum possibility is with the help of n plus 1 points, you can able to create nth degree polynomial. Means with the help of 4 points, maximum possibility means you may able to create third degree polynomial. Suppose these 4 points are lying in this non-linear position. Suppose 1 point is here, another point here, another point here, another point here. So if you will try to join this point, looks like this type of curve, it will be a cubic polynomial, suppose. So with the help of 4 points, you will get here third degree polynomial. But if the point beside that, suppose your 4 points is lying on the straight line. Okay. So with the help of 4 points only, you may be able to approximate here a first degree polynomial, that is the straight line. So maximum case is maximum, that is why I have used here the maximum word. Okay. With the help of n plus 1 point, you can able to approximate maximum nth degree polynomial. If the points are lying in linear pattern of the joining curve, then your degree will be reduced. Otherwise, it is the maximum possibility. Is it clear?
Yes, sir.
Second statement looks like same, but it is in another way, indirect way. Direct way, that was direct way, it is indirect way. To create a nth degree polynomial, you need minimum n plus 1 points. This statement is true. Suppose a छोटा सा question, you have to create a first degree polynomial. First degree polynomial is the straight line, isn't it?
Yes, sir.
Now you just tell me, first you are creating a polynomial, this polynomial suppose. To create this polynomial, how many points you need? You need minimum 2 points. You need minimum 2 points. Suppose this 1 point is here, another point is here. With the help of these 2 points, if you will try to join these 2 points, you will get this straight line. Beside that also you may, suppose you may have, here is also point, here is also point. And that 4 points you are joining, you will get a straight line, but that is not matter. Minimum 2 points you need to construct this straight line. Okay. So एक straight line first degree polynomial बनाने के लिए 2 point चाहिए. Simply you are going to approximate a parabola. Parabola will be looks like this type of things. For that purpose, it will be looks like, suppose here is 1 point, here is another point, here is another point. You are joining this point in this way, and you are constructing a polynomial, that is the second degree polynomial, and it is a parabola. Okay. Similarly, to construct nth degree polynomial, you need minimum n plus 1 points. So this statement is also true, isn't it?
Yes, sir.
Now I will use the idea of straight line creation. Are you seeing these 2 points I am considering? Suppose this point is your given data sets is simply for this given data sets is suppose x1 and x2 and corresponding y data is y1 and y2. These data sets x and y is given to you, and you are going to approximate a polynomial with the help of these 2 points x1 y1 and this point is x2 y2. Okay, so simply you are joining. So what is the equation of the joining line straight line? If 2 points is given to you, what is the definition of this straight line? Can you able to construct that straight line by this formula? Are you able to see this formula?
Yes, sir.
So after y minus y1 by y2 minus y1 equals to x minus x1 by x2 minus x1, you will get, after doing the little bit manipulation or calculation, you will get y equals to function of x. And that calculation, after doing that calculation, y equals to function of x, that curve I am writing in this pattern. And that pattern you just try to remember. Straight line equation is this pattern. You just try to remember this pattern, because this pattern I will use for the more points. With the help of induction process, step by step, suppose for the 3 points, what will be this formula looks like? For the 4 points, what will be this formula looks like? In that way, for the n plus 1 points, what will be the formula looks like? We will establish a general formula with the help of n plus 1 points, nth degree polynomial, and that will be the Lagrange's interpolation. Okay, that is I have done at the last. Okay, that is the Lagrange's interpolation. Okay, so first of all, you just see, after doing the calculation of straight line, it is coming looks like this or not? It is coming looks like this or not? Y equals to approximately x minus x2 by x1 minus x2 into y1. X minus x1 by this will be x2 minus x1 into y2. How you will remember this? Or you just see this pattern and try to establish the formula for 3 points. Suppose 3 points is given to you, looks like this. X0 at x0, y0 at x1, y1 at x2, y2. These 3 points are given to you. Then approximated polynomial will be the second degree. And that second degree polynomial will be y equals to pi x equals to, in numerator, in first term, suppose first term I am telling you to remember. You just, in that way, you just try to remember. In first term, what I am doing here, in numerator, first value, except first value, remaining all x value I am subtracting, and that linear factor I have multiplied. First value is x0. So except x0, how many points? x1 and x2 is there. So x minus x1 and x minus x2, that two factor multiplied in numerator. And denominator will be from first value to remaining all x value, you just subtract. First value to remaining all x value, you just subtract. That linear factor you just multiply. First value is x0, x0 minus x1, x0 minus x2, that is the numerator. And associate coefficient is y0, corresponding y value is y0 in first position, that is you just multiply. That is the first term. Can you able to do this? So what will be the second term? So except second value, remaining all x value, you just subtract x minus x0, x minus x2, and from second value to remaining x value, subtract in denominator. Second value x1, so x1 minus x0, x1 minus x2, and corresponding second y value y1 multiply. And for the third term, third value, except third value, remaining x value, you just multiply, subtract from x and multiply the linear factor, x minus x0, x minus x1. And in denominator, from last value, remaining all x value, you just subtract x2 minus x0, x2 minus x1 into corresponding y value. That idea for the lots of points, can you able to establish? You just see the pattern of this formula. It is coming from the 2 points, then 3 points. If I will give you n plus 1 points, that general formula, can you able to establish? Again, you just deeply watch this formula and tell me. Okay, sir, we can able to do.
Yes, sir.
You see and watch, and you just see the last term. This is here you do have n plus 1 points. General formula we are going to establish with the help of n plus 1 points nth degree polynomial. So what will be the first term? Y equals to approximately function of x, and that is first term with respect to in numerator, except first value remaining all x value I am subtracting. X remaining x values are x1, x2 up to xn. So x minus x1, x minus x2, x minus xn. In denominator, from x0 you just subtract all x value. X0 minus x1, x0 minus x2, x0 minus xn. So these are the variable. Actually, numerator is the variable, denominator is the numerical value. Suppose this is the numerical value. In the data sets, it will be given to you. So after doing the calculation, it will be reduced. And associate first y value, you have to multiply it, and that is your first term. How many terms you will have here? In that way, जितना point उतना term होगा. How many points you do have? N plus 1 points, so n plus 1 term is there. Okay, so you have to construct in addition way n plus 1 term step by step. So in this process, the process is very easy, but lots of binary operation is there. So it will take lots of computational time, and that is the main drawback of this technique. Okay. So one general kth term I am establishing. Okay. In between you do have a value xk. So kth term I am establishing here. Suppose what will be the kth term? From x, every x value you just subtract except xk. So x minus x0, x minus x1, x minus x k minus 1. Then next value will be x minus xk plus 1. Xk term I am not considering because in denominator I will subtract all value of x from here. Okay. And dot 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 x minus x and last one. In denominator it will be subtract all value from xk, xk minus x0, xk minus x1. This term will be xk minus xk minus 1. This term will be xk minus xk plus 1. Why not middle value? If I will subtract xk minus xk, denominator will be 0, so it is undefined term will arise. So in that way also you try to keep that concept in mind, why that value is not subtracted here. Okay, and corresponding y value is yk is multiplied in associate term or as a coefficient. In that way, last term. So if you will do complete this process, this polynomial y equals to 5x, this polynomial is known as the Lagrange's interpolated polynomial, and process is the Lagrange's interpolation. Is it clear?
Yes, sir.
Okay. For the verification purpose, I am considering actually you just do a closure loop here. Okay, and try to remember. I am constructing here a simple example. For the verification purpose, I am considering the same example. Suppose 0, 1, 2, 3, and it is I am considering 1, 3, 9, and 27. Okay, this example you have done lots of time. Basically, for this example, if I will ask you find out the values of y at x equals to 4. Obviously, suitable technique is Newton backward interpolation, but with the help of Lagrange's interpolation, what it will come, that is you just calculate. Basically, to remember that formula, for that purpose, I am giving you this example. Okay. Beside that, I think in backward interpolation, what was the result was there? In backward interpolation, somebody you have got result somewhere. This type of example I am dealing every times. Now, let me ask you to construct the polynomial y approximately function of x. What will be the first term? First term, how I am writing first term? In first term, I have to multiply it corresponding y first value means 1. What will be the numerator? Except first value remaining x value subtract. X minus x1, x minus 2, x minus 3. What will be denominator? From first value remaining x value subtract. 0 minus 1, 0 minus 2, 0 minus 3. This is your first term. Okay. What will be the second term? Except second term, remaining all x value subtract in numerator. X minus 0, except second. So x minus 2, x minus 3. Denominator will be 1 minus 0, 2 minus, 1 minus 0, 1 minus 2, 1 minus 3, and corresponding y second value means 3. What will be the third term? Follow numerator, follow x minus quickly.
X minus 2 into x minus 3 into x minus 0.
X minus 0, you just write down first. X minus 1, x minus 3. And from 2, you just subtract all x value, means 2 minus 0, 2 minus 1, and 2 minus 3. And corresponding y value is 9. Plus last term, you just tell me from except last value, all x value you just subtract x minus 0.
X minus 0, x minus 1, x minus 2. Divided by 3 minus 0, 3 minus 1, 3 minus 2.
3 minus 1, 3 minus 2. Corresponding y value you have to multiply 27. This is your approximated polynomial, and this is in Lagrange's interpolated polynomial. Lagrange's interpolation. In that polynomial, you have to put values of x equals to 4, and whatever the result you will get, that is the approximate answer. Okay. So actually, if I'll write y at x equals to 4, then value, approximate value will be, first term will be, so 4 minus 1. 4 minus 1 means, you just do little calculation. Okay. 4 minus 1 means 3. 4 minus 2 means 2. 4 minus 3 means 1. By minus 1, minus 2, minus 3. Minus 1, minus 2, minus 3 into 1. What will be the second term? 4 into 2 into 1 by 1 minus 1 minus 2 into 3. What will be last third term? 4 minus 0 means 4, 3, and 4 minus 3 means 1. By denominator 2, 1, 2 into 1 into 2 minus 3 means minus 1 into 9. What will be last term? 4 into 3 into 2 by 3 minus 0 means 3, 2, and 1 into 27. So can you able to calculate this now? And what is the approximate value is coming? What is this term? First term 6. 6 by minus 6. Minus 1 into 1 means minus 1. Okay, what is this? 2 cancel, and this minus minus plus. So it will be 4. 4 into 3 means 12. Okay. This is minus term, simply 1 minus is there, so 1 minus will come. So 2, this is 2, this is 12 by 2 means 6. Okay. And simply 1 minus is come, so minus 6 into 9 means minus 54. And what will be this term? This 3 cancel, 2 cancel. So 4 into 27. 4 into 27 means 108. And what is this value now? Just tell me.
$65, sir.
65. So you are, if you just try to do, you will get in Newton backward interpolation also nearby 65, that type of result. Okay. But you are not getting, if the graph is looks like y to the power 3x, at the top I have written this example. It looks like y to the power 3 to y equals to 3 to the power x. Looks like. And if I will put in place of x 4, it will be 81. Isn't it? But you are not getting 81 in mathematical techniques. Okay. So that is the error, and that is why whatever the value you are getting, that is the approximate, always you have to tell. This is the better approximate or approximate result. Method is clear?
Yes, sir.
Lagrange interpolation. What is the drawback and plus point of this technique? Main drawback is, in this interpolation, it will contain lots of binary operations. Suppose you do have n plus 1 points, you just see. So n plus 1 terms you have to consider. In every term, there are n factor multiplication in numerator, n multiplication in denominator, as well as right hand side multiplication. So that is simply one term. In second term also that type of binary operations will be performed. So huge binary operations are involved in this technique. So computational time taking is high. And that is logically main drawback of these techniques. Okay. An advantage is you may be able to establish inverse interpolation. Suppose you have to find out at some other point the values of x at particular y. Suppose y equals to yp is given to you. And that yp is not related to these data sets, outside or inside some other point and not related to that point. And y is given, x you have to find out. So that time you may be able to establish same way the formula in inverse way by replacing x by y. So that time this value you will consider x and this value you will consider y. Okay. And you just write down x equals to function of y, x equals to function of y. By replacing x by y, you will get inverse interpolation formula. So for these techniques, inverse interpolation formula is able to establish. So that is the advantage. Advantage and disadvantage. And one important things you may ask, suppose you do have lots of points, suppose 4 points. This type of 4 points you do have. And you are going to establish the Lagrange's interpolation. And that 4 points are lying on the straight line. So obviously with the help of 4 points, initially you have to write the structure of the cubic polynomial. Means 4 term you have to write. But in the calculation, it will reduce your binary calculation, and at the last you will get the lesser degree polynomial. At the last you may be able to decide which things for the Newton forward, backward and divided difference you are deciding by watching the difference table, how many degrees of polynomial you are going to establish. It was be decided therein by watching the difference table, but here after doing all calculation, at the last you may be able to decide which degree of polynomial you are going to get. Okay. So suppose any other data sets is given to you, can you establish this formula, and using that formula can you able to calculate values of y or approximate value at some other points? This example I have given you for the verification purpose or for the understanding purpose of these techniques. Very easy example, but in exam you will get minimum 6 or 7 points. So on that basis you have to do the calculation.
Excuse me, sir.
Yeah, you can ask.
Sir, this is only applicable for equally spaced data set.
No, this is applicable for uneven space, equal space, uneven space for all elements, and that is the also plus point. Suppose in last class I told you calculate, suppose x, y, suppose 0, 1, 2 and 4 corresponding value was there in divided difference. What was 1, 3, 9 and 81 was there. Okay, and you have to calculate values of y at x equals to 3. That time also you may use divided difference or Lagrange interpolation. That time Newton forward and backward is not applicable. Okay. Simply for equal space arguments, Newton forward and backward, and for uneven space or unequal space arguments, Lagrange's interpolation and divided difference interpolation. Okay. So Lagrange's interpolation having only one plus point, you may able to establish this formula as an inverse way. Suppose sometimes you have to calculate values of suppose x. What will be the values of x at suppose y equals to suppose 80? That time you have to establish the formula x equals to function of y in Lagrange's way. That time you have to consider in this way, these values are the x value, these values are the y value, and same way you just replace x by y or y by x and establish x equals to function of y in inverse way. That is the plus point. Drawback is lots of binary operation. Otherwise, for the unequal space, you just try to use divided difference interpolation. And for the equal space argument, Newton forward and backward.
Okay, sir.
Okay. So on scientific logic and with the help of operator, I am going to calculate this value. Suppose same question I am writing in this way. Suppose some competition purpose, it is asking you find out the missing term. And question I am writing in the same way actually. You are seeing these x values are equally spaced, looks like actually. This x 0, 1, 2, 3. 1, 3, 9 and 27, and at the 4, that is the query point. Okay, sometimes you will get this type of question. That is also same question actually, isn't it?
Yes,
that
sir.
is also some question. So to calculate this, you may use any technique. Okay, suppose this is the given data sets actually. This is your given data sets. So in the given data sets, x values are equally spaced. So you may use asking point is suppose x equals to 4. X equals to 4 means 4. That is the asking point. It is lying ending neighborhood. You may use Newton backward interpolation. If you use Newton divided difference or Lagrange's interpolation, that time also you will get the result. Okay, for equal space arguments, also you may use the divided difference and Lagrange's interpolation. There is no any restriction. But for the uneven space arguments, obviously you cannot able to use Newton forward and backward. Okay, so now I am not using any interpolation techniques. Simply I am going to use some scientific logic, and with the help of operator I am trying to calculate this. Okay, so that logic is, suppose how many given points you do have here? Non-given points is only 4.
Yes, sir.
With the help of 4 points maximum, which degrees of polynomial you can able to approximate? Maximum. With the help of 4 points you may able to approximate maximum third degree polynomial.
Yes, sir.
So whatever that polynomial, third degree polynomial, its third difference constant and fourth difference will be 0.
Yes, sir.
Del 4, suppose del 4 y will be 0 for the given logic. That is the scientific logic. With the help of 4 points, we can able to approximate maximum possibilities third degree polynomial. So whatever that polynomial it is,